Hello and welcome to my talk. My name is Tim Retz. I'm a postdoc at the Institute of Philosophy from the University of Bern, and I will talk about group fairness and in particular the notion of independence. Here's some background, go on results. So the debate on fair machine learning has picked up momentum after the 2016 ProPublica article on compasses, you probably all know. And this debate has focused on three kinds of group fairness measures: independence, sufficiency, and separation. So independence is also known as statistical parity and demographic parity. Now, when I read this literature, I got the impression that the community is somehow skeptical about independence, and more so about independence than about sufficiency and separation. And it seems to me that this traces back to two influential papers, one by Dwork from 2012 and one from Hart and co-authors from 2016, both with more than 1,000 citations. Now, the goal of today's talk is to revisit these two papers and see whether the bad reputation that independence has is well deserved. And the result will be that arguments against independence apply equally to other kinds of group fairness, or they are not that strong. Okay, so it's a brief outline. First, I have a remind you of the definitions of group fairness. Then I'll look at the arguments from these two papers. Then I'll give you an argument for independence, and I'll give you some final thoughts on how to reason about fairness measures in general. Okay, here are the definitions of group fairness that I will be using. So they're always based on random variables, which will, in all the examples, those will be binary. So we have the predictor R, you have ground truth Y, and you have the sensitive characteristic A, or group membership A. So first, the three measures of group fairness. First, independence is just that the prediction is statistically independent of A. Then we have two that are conditional independent statements. First is that the prediction is independent of A given Y. So in these causal diagrams or Markov chains, Y screens off R from A, or everything is mediated by Y, and for sufficiency, everything is mediated by R. Then we'll need individual fairness. Informally, this means that singular individuals get similar predictions or treatment. Negative legacy is unfairness that is due to unfair sampling or labeling of training data. Okay, let's look at the first argument against independence from the paper by Dwork et al. This argument I call the argument from gerrymandering. So here is what Dwork et al. Have to say about independence. We demonstrate the inadequacy of statistical parity, which is the same thing as independence, as a notion of fairness through several examples in which statistical parity is maintained, but from the point of view of an individual, the outcome is blatantly unfair. And so what they present in the paper are several examples. And so here on the right, I've tried to sketch this. So this is example one from their paper called reduced utility. And in this example, you want to hire people from two groups, P and Q. And people are vertically ordered by suitability with similarly suited people at the same height here. You hire people from both groups according to a binary decision rule R, and here you have an example of R on both sides, and in this example, or for this R, independence is satisfied, but the least qualified members of P and the best qualified members of Q are selected. Now, also, two individuals from P and Q can have similar properties, but they are not treated similarly. And now this can arise as an accident because the people doing the hiring are not really all that familiar with people from group P, or it can be a malicious hiring practice. Now, this argument is fine as far as it goes. Now, the problem with the argument from gerrymandering as specifically directed against independence, that, well, they can make a similar argument for separation and sufficiency. So here I've created this very similar scenario in which the same happens for separation and sufficiency. So again, we have two groups now with the additional information about actual suitability, which is just a cutoff rule here. So you have red are the unsuitable people and green are suitable people. R is again the decision rule. Now for this choice of R, separation and sufficiency are satisfied because equal proportions of red and green people from the groups are selected. And now we hire the most suitable people, conditional Y from group Q, and the least suitable people, conditional Y from P. Now, in this example, you again have gerrymandering, and you also have violations of individual fairness, as you can see here with the horizontal arrows. Okay, so this might seem to those who are familiar with the work or the paper by Dwork et al. That this is somehow unfair. So let me put this a little bit into context. Now, first of all, we should ask, do Dwork et al. Really wish to reject independence? So on one hand, you have the quote that I've given you at the beginning, where it seems that yes, they want to reject independence, but later on they write statistical parity is insufficient as a general notion of fairness, and this gives us some leeway. Maybe it's useful in some situations and not in others. Then it's important to emphasize that the above argument does not show that Dwork et al. Are wrong, but that their argument equally applies to other measures of group fairness. And this, raises the question, why did Dwork et al. Not appreciate this? And one plausible explanation for this is that measures like sufficiency and separation, so other measures of group fairness, were only more widely discussed after the ProPublica article, which appeared in 2016, but Dwork et al. Was already published in 2012. So it could well be that the fact that Dwork et al. Only attack independence as opposed to it attacking group fairness in general is a historical accident. Okay, let's turn to the second paper and the second argument against independence, and this is the argument from accuracy in Hart et al. So what are Hart et al. Saying? They write, demographic parity, which is the same as independence, often cripples the utility that we might hope to achieve. Just imagine that the common scenario in which the target variable y, whether an individual actually defaults or not, is correlated with A. Demographic parity would not allow the ideal predictor, R equals y, which can hardly be considered discriminatory as it represents the actual outcome. As a result, the loss in utility of introducing demographic parity can be substantial. Unlike demographic parity, our notion, which is separation, always allows for the perfectly accurate solution. So here on the right, you can see I try to reconstruct part of this argument. The argument runs as follows. First premise, a perfect predictor is maximally fair because it aligns with the actual outcome. Second premise is that independence is not generally compatible with a perfect predictor, while separation is compatible with a perfect predictor, which is correct. That's just a mathematical fact. The first conclusion from this is that, therefore, independence is not generally compatible with a maximally fair predictor, while separation is. And from this, again, they conclude, therefore, separation should be preferred over independence. Now, I want to argue that there are two things wrong with this argument, and I will show what. So, problem one is the step from conclusion 1 to conclusion 2. So the step from, or the inference from independence is not generally compatible with a maximally fair predictor to therefore separation should be preferred over independence. The problem is that there are virtually no perfect predictors, as computer scientists often point out. So while theoretically interesting, perfect predictors are practically irrelevant. But this raises the question, why should we base our preferences of fairness measures on a property that virtually never occurs and thus is practically irrelevant, as desirable as it may be? Now, maybe it could be thought that you can somehow save the argument from accuracy by making it weaker and saying, well, it does not only apply to perfect predictors, but also to increments of accuracy. And in fact, Hart et al. Seem to think that the argument works in this case as well. They write, our criterion, that is separation, is easier to achieve the more accurate the predictor is, aligning fairness with the central goal in supervised learning of building more accurate predictors. However, the claim that separation is preserved under increments of accuracy is demonstrably wrong. This is just something that you can prove to be wrong. And so you can find the proof in the paper. The proof idea is very simple. You construct a confusion matrix, or actually two confusion matrices for the two groups with an imperfect predictor that satisfies sufficiency and separation. And now you increase accuracy in a certain way, and you see that you lose both sufficiency and separation, so they don't hold anymore. Okay, let's turn to the second problem with the argument from accuracy. That's premise 1, which is that a perfect predictor is maximally fair because it aligns with the actual outcome. This essentially means that, well, the distribution of ground truth with respect to a group is fair because, well, the other way around. So first, the distribution of y and a is fair, and because R aligns with y, the distribution of the predictor with respect to the group variable has to be fair as well. The problem with this is one of the problems with this from a philosophical perspective. The status quo captured by the distribution of y and a is not a moral category. It is just a description of what we find in the world. But finding the world to be a certain way and inferring from this that the world ought to be this way is committing a fallacy, a confusion between facts and values. So this is also known as the is-ought gap. Okay, so these were two arguments against independence that I scrutinized, but this doesn't mean that independence is a good idea. And so here's one argument for independence that actually turns one of the arguments against independence on its head. So sufficiency and separation are formulated using y. They are thereby, in some sense, measures of how deviations from y are distributed. They're measures of errors with respect to y. And it could be thought that this is a virtue of these measures. However, this also creates problems because sufficiency and separation are silent on the question whether the distribution of y itself is fair. Independence, on the other hand, is not a measure of deviation from y because it is, well, independent of y. and it can be used to correct for unfair distributions of y. And specifically for accurate predictors, violations of independence suggest negative legacy, and we can consider modifying R to get closer to independence. Okay, getting to the conclusions or lessons that we can learn from this. First, it's important to always explicitly state the moral values underpinning a fairness measure, as opposed to descriptive properties such as accuracy. Second, gerrymandering, as we have seen in the discussion of the work paper, is a problem shared by all group fairness measures. And one possible solution that has already been explored extensively is combination with individual fairness. Third, this is also, I think, well known in the literature, choosing group fairness measures is context dependent and more specifically dependent on normative properties of contexts. And all of this suggests that none of the group fairness measures is logically necessary or sufficient for fairness with a capital F. Thank you for your attention. And this is the bibliography. Thank you.